Hello everybody, my name is Sumit Gupta and today I'm gonna present you a demo on my final project, and I will be using AWS Storage Gateway Service for my final project. So the problem description for my project is company ABC use MySQL database to store all their data for online applications. Their problem is that they have only one data center, and with just one data center they are not equipped in case of a disaster. So they are in danger of losing all their data if something happens to that data center. So to maintain business continuity, AWS Storage Gateway Service is used in my project. So going to the AWS Storage Gateway, so we can use it Storage Gateway in three configuration. The first one is Gateway Cached Volumes. Using this service, primary data is stored on S3 and frequently accessed data is stored locally for better performance. You will get low latency if it is stored on premise. It reduces your primary storage cost. The second way we can use it is Gateway Stored Volumes. In case low latency data access is required, storage volume could be used to asynchronously back up your data to Amazon S3. This service could be used to reduce storage cost, and in case of disaster recovery you can maintain business continuity. The third one is Gateway Virtual Tape Library, which we can call it as Gateway VTL as well. Using this service you can store your less access data to virtual tape, which is backed by S3 or Amazon AWS Glacier. The virtual tape library exposes an industry standard CSCI interface which provides your backup application with online access to the virtual tapes. So in my project I'm using the second configuration, that is Gateway Stored Volumes. So without much ado, let's move on to our project. Okay, so let's start with the demo. To start with, you should have an AWS account. Log into your AWS account. Make sure that you have subscribed to Storage Gateway service. Click on Storage Gateway. Here I already have deployed a gateway, but let's deploy a new one. In my for my demo I'll use Gateway Stored Volumes. So what it does, it schedules offsite backups to Amazon S3. Whatever data we are having on premise, it schedules the backups to the S3 as well. Click continue. So for this, to implement this, we need to provision a host. We will go through that step later. Continue. And for the host, we will use for our demo we will be using VMware ESXi. Here you can download the AWS Storage Gateway Virtual Machine software. Just click on download and the virtual machine file will get downloaded. We have already downloaded it, so let's click on continue. So let's get back to creating a host first. So as we saw in our previous option, that we want to create the host, the VMware ESXi host. So let's go and download VMware ESXi from the VMware site. So you need to log in, create a login on the VMware site, and here you can go on. So download the VMware ESXi from the VMware site. You need to create a login ID to download the VMware vSphere Hypervisor 5.5. Once you have downloaded that, download VMware Workstation, on which we will create the VMware. We will actually create the virtual machine, that the ESXi. For our project, I downloaded VMware Workstation 10. So here it is, and let's open VMware Workstation 10. So this is my VMware Workstation 10, and I created a VMware. I actually created a virtual machine VMware ESXi5 earlier. Let's start and create another one. New virtual machine. Let's keep it as custom. New. Next. So here you're gonna choose the installer file, ISO file, the ESXi file which we downloaded from VMware site. Click next. We will give it a different name. Click next. Let's increase the number of processors here because there is a minimum requirement for ESXi virtual machine to run. Next, we will increase the RAM as well. So my laptop has 16 GB of RAM, so let's assign somewhere like 8 GB. Click next. Here we will be using bridge networking so that for the IP address to get allocated. Click next. Leave these as defaults. CSCI is recommended. Create a new virtual disk. Click next. And here this is an important step. We need to make sure that this has a lot of disk size here because we allocate the disk size for our storage device as well. So for our POC, we'll keep it as 130 GB. Click next here and leave this as default. Next and finish. So this virtual machine, we have just imported it. Now power on this virtual machine. Click on power on. This VMware, this virtual machine will take some time to get booted. First it gets installed. So it says automatic boot in 4 seconds. So currently it is loading the ESXi installer. This takes some time to actually load the whole package and install the VM. So click enter to continue, F11 to accept and continue the license agreement. Now it is scanning some available devices. So click again enter to continue the installation. Leave the US default as the keyboard layout. Here you need to enter your root password. Click F11 for installing. So we see now that ESXi 5.1 has been successfully installed. Now let's enter to reboot the virtual machine. This will take some time. So it's getting rebooted now. So here we see that an IP has got allocated to this virtual machine. Let's go and type this IP on our Chrome browser 10.0.25.130. Proceed anyway, and see we can download VMware vSphere client from here. So I already downloaded a vSphere client, so I will connect to this machine through the VMware vSphere client. So our IP address is 10.0.25.130 and our user ID and password which we set up during the ESXi installation. Click login. No. We'll get this message. Now here is our ESXi server. Now let's create now let's deploy our OVF template. This is the same template which we downloaded through our AWS client. So we downloaded that. Click continue. We created the host here. Now we are using VMware ESXi server. Here we downloaded this OVF template and we will be importing that template here. So click next. We'll name this as AWS Gateway Storage -demo. Click next. Leave the defaults and finish. It will take some time for this VM to get created. So basically to use AWS Gateway Storage, there are a lot of steps which you have to do outside AWS console. So these are the steps which you are performing, and later on we will go back to the AWS console. So we see that it has deployed it successfully. Let's do close, and we can see our storage gateway VM here. We need to edit our virtual machine settings. Let's go to options, general, options, VMware tools, synchronize guest time with the host. Go back to hardware. We will add some hard disk devices here for our storage and the buffer cache. For our POC, we'll keep these hard disk devices really small, that is 3 GB. Finish. Let's add a couple of more. So we added some 4 disks here. Now let's change the CSCI controller type to VMware para virtual. So these are the recommended settings from AWS itself. Select OK. Now let's power on this virtual machine, and we will go to summary tab here. So IP address will appear here for this virtual machine. Going to the console, we can see the this virtual machine is getting booted here. Now let's get back to our AWS console. We'll continue these steps we just followed. We'll continue again. Let's go forward. Provision some local disk storage. We created 4 disk storage here. Now we created one more for the disk for the upload buffer. We'll go here, and the IP address, this IP address will be the same what we are going to get here in the summary tab. So login would be SG user, and the password. Okay, so let's get back to summary tab. So we have got an IP address here. So the same IP address we will be using on our AWS console, 10.0.25.60 10.0.25.60, and proceed to activation here. Let's try again here. 10.0.25.60 and proceed to activation. Here it is. So this works now. Let's give some name to our gateway, demo, and activate my storage gateway. Okay. Could have changed to the Eastern actually. Yep. So I can see my demo gateway here. It's getting loaded. Let's create a volume now. Click on create volume. Seems like my internet connection is kind of slow. Okay, so as you saw, we created 4 disks while after we created our virtual machine gateway. So we'll choose one of that. We give it a my volume demo. There is no snapshot here. We'll create a volume. Now we will configure a local upload buffer. We will choose the second one, next, and confirm. And so here we will create an alarm that whenever my upload buffer size utilization exceeds 50%, send a notification to my email ID. Continue, and our volume is successfully configured. See, the status here is available. Now let's mount this volume on our laptop using CSCI initiator. I'll open my initiator here, go to discovery, discover portal, and add the IP address, that is 10.0.25.60, and click OK. So here it is. Here is our demo IP address. Go to target. So we can see my volume demo is inactive. Let's connect to it. It says it's connected. Once this is done, let's map this disk to a drive name. We will type disk empty.msc. Just say OK. And so we can see that there is a disk of 3 GB unallocated. Do a right click, new simple volume, next, click next. This will be named, let's give it a name as K, next, perform a quick format, next, and finish. This will take some time. To get formatted, and once it is formatted, we will go back to my computer and see if this disk we can see it there or not. Actually, it is already here. So also here we on the disk management we see this partition is healthy. So now that we have a volume here, we can start storing our backups on this volume, and this will once we start storing here, this will get backed up on S3. So as discussed earlier, my demo here is to take a backup of my MySQL database, which is running on premise, and this will get backed up on EC2 EBS backed volumes. And if during a disaster recovery, I can use that volume to and map it to a EC2 instance and start my MySQL database there itself. So I have created I have a MySQL database. I have a test database with couple of tables there, department and employee. Let me run a query here. Select star from test.dbt and just to see the data. I have 8 records here, and I have a batch script which is gonna run and take the backup of the script and store it in this volume. So I'll go and run my batch script here. Slash and backup.bat. So what it will do, it will take the backup of my database and place it here. So I can see that my database.sql is here. Now let's create a snapshot for this particular volume. Create a snapshot. So it was initiated successfully. To see the status, we can go back to snapshot here, and we can see here that the snapshot status is currently pending. So here we see that our snapshot is completed. So before taking this to the EC2 level, let's copy this snapshot ID here and mount a new volume here. Let's create a new volume using this snapshot and map it back to my laptop actually. So here I'll give this my volume snapshot, and here this time I will give the snapshot ID. This is to prove that whatever data was there in my first volume, that is K drive here, if I map a volume here back with the snapshot ID, it will have the same content. So create a volume, refresh here. Yeah, so it is currently in restoring status. So it will depend on how fast the restore happens based on the amount of data we are trying to restore. We can see the progress of restore here itself by clicking on the volume. It is currently 37%. So in the meantime, let's open another AWS management console and create an EC2 instance there. EC2 instance. So instances, I already have one. I'll launch another instance here. So this first instance is backed by has MySQL in it, and since my database backup is a MySQL, so let's select this and click configuration details. No preference here, or rather let's see where our volume is located. So let's go no preference, stop, add storage. Here the security group, we will select an existing one. I have a default group, review and launch. And I will choose an existing key pair, that is acknowledge and launch instance. Let's get back there and see if this restore was complete. Not yet. So now we can see this the volume is available. Now let's go to CSCI initiator that see volume snapshot is inactive. Let's connect. It is connected now. Now we will go back to disk management so that we can map this to a letter, and it could be mounted on our laptop. See, so this is the disk. It's in offline now. Let's bring it online, and we can see that it already took a partition name that is an E drive. Now we'll go back to our My Computer. See, we can see our E drive here with the MySQL database backup file here. So we can see how our on-premise backup got transferred to Amazon S3 and we can take regular snapshots to keep our backups in sync. So we can see the snapshot schedule is also there. For each of the volume we have currently every 24 hours a snapshot would be taken, and we can anytime modify it to whatever frequency we want to have. Now let's go back and see if our EC2 instance, it is still initializing, but here we can see our snapshots here as well on the Elastic Block Store. So click on snapshot, and let's check what is the snapshot ID. It is snap A494. So this is the one for our demo. So we will create a volume for this snapshot. Volume type would be standard, and go back to volume and see, and let's check if so this volume is available to use. Let's go back to our instances and see whether my instance came up or not. Let's wait for a couple of minutes before the status check gets over. So we see that our instance is up and running now. Let's connect to this instance using Sigwin. cdc:// yes. Yep, so here we are connected to our EC2 device. Currently I can see that there is no we don't have our storage volume attached to this device. We'll go back to the screen, go to the volume. Before that, go to instance, and let's take the name of our AMI. Instance ID is I7A 0D591C. Go to the volume, select our snapshot volume, actions, attach this volume, and here we will attach it to our running instance. We need to make sure that we know what is the name of the device. Here it is /dev/sdf, and let's do a attach. So once it is attached, the status will be in use. So let me see. So here we can see that our volume got attached here to our, this was our volume ID, snapshot ID actually. So This is our snapshot A49, and this got attached to our EC2 instance. Let's go back to EC2 instance and just check if the volume got attached. We can simply go to cd/dev and do a list, and here we can see that SDF got attached. So before attaching this disk, let's install MySQL on our EC2 instance. So what we are trying to do here is, suppose in a disaster recovery, to maintain the business continuity, what we want to do is that since all these backups are being taken from our on-premise to S3, these snapshots could be restored and attached to the EC2 instance. And your database will be back up within minutes if once you can take these backups and restore in the MySQL database which is present on EC2 instance. So MySQL is getting installed now. Now let's start MySQL service. So MySQL has been initiated now. Now let's see if MySQL is running. It is. Now we will change the username, sorry, not the username but the password for the root user. See, let me find out what the error is. Let me run this again. Okay, so the problem here was that I ran this MySQL when I was using the EC2 user. As soon as I sudo my user ID to root and then ran this command, my password got updated. Now let's run another command, paste, and let's exit now and try to mount the volume on this system so that we can use that backup file and restore our database on EC2 instance. Let's create a directory here, make dir /mt/us image. This is where we are gonna mount it. Now we will run a command. So these are the steps which we followed in one of our assignments as well. I use the dev SDF because this is how this is the name of my volume. Now do a cat on our etc fstaff file to see if the entry got registered. So yes, I can see it. Now let's mount our volume on mount EBS image. They say you must specify a file type. Yeah, okay, -t ext3. So I'm getting some error. Let me check that. Seems like it got changed to SDF1. That's super block 9. Let me check again. Let me run this command and see what it does, and then the mount command for SDF1. Before that, see, make dir /mnt/backup, and then mount /dev /sdf1 /mnt/backup. So it works. Now let's go to /mnt/backup and see if we have our file or not. So we cannot see that file, so let us debug more. So since we are getting error, let's do one thing. Let's detach this volume and reattach it. think so. The snapshot ID, I think so, it was I7A0 it is attached to. Okay, this is my A494. okay, so this is the one. We will detach this volume and let's wait for it to become available, and then we will reattach it to the device, to the EC2 instance, and see if we are able to mount it or not. So I have reattached it to my EC2 instance, and let's see now what happens. So to figure out this issue, I created another snapshot 5969. Let's go back here to the snapshot and try to create a volume from this snapshot and attach this one to our EC2 instance. So this is our new snapshot. Create volume, volume type standard, and just before this, let me do instances. It's running on East 1A, so volume. Let's go back to snapshot and 5969, select it, create volume. That's fine. Standard, yes, create. Now let's go back to volume. So this is the volume which got created. Now we will attach this to our instance, and this we can see it is dev/sdg. Yes, attach. Okay, now it's in use. We will go back to instance, click on the instances, and here is the dev/sdg. It is saying the block device status is attached. Now let's go back to our EC2 image, and now let's retry this to mount dev/sdg. So mount /dev/sdg to /mnt/new vol. Okay, it needs a file system ext3. So we are still getting this message. So at last I was able to mount my file system. I had to recreate a snapshot and create a new volume out of it and attach it to our system, and here it is. We can see that after running this adding this mount to the fstab file and running this mount command, I can see that my mydatabase.sql file is here. Now we know that MySQL is already running here, so let's try to restore this file to our database which is running on EC2. 9. Let's go to MySQL. Okay, so now we are in the MySQL. Let's see, show databases, which all databases are here already. So we see that there is a test database. Now let's try to restore our backup file on in this test database. So let's run this command so that we can restore it. It says permission denied. Okay, so we need to run it with the sudo command. Okay, sudo. Okay, again I'm getting the same error. Okay, so I was getting that error because my database.sql is a read-only file and EC2 user doesn't have that access. Now let's try to run it. MySQL minus root sp. Okay, so I am inside that, so I will run the backup command again. Okay, so I don't find it here. So this is my backup command. Let's provide me the password here, and it seems the database got restored. Now let's get into MySQL and show databases, and I will run a select star from test.dbt, and I can see all my 8 tables are here. Oh sorry, all my 8 records are here, and my table department and employee ID is here in the test database. So with this we can see that how if in case of disaster recovery, business continuity can be maintained if we are storing all our backup files from the premises, from your own premises to the S3, and on S3 we can just restore those backup files on any of your databases of your choice, and your system can be up and running again. So that's all for my demo for this project. In this demo we saw that either we can mount the snapshots on our drive itself, on our computer itself, like we mounted here, or in case of disaster recovery, you can just go to your EC2 image and and mount that volume on an EC2 instance, and your database could be up and running within minutes. So that's all from my side as part of this demo, and detailed documentation of each and every step is also in the detailed documentation which I'll be attaching with this project. And thanks everyone. Thank you.